Welcome to our new episode of IoT and IP Explained. I am your host, Claudia Tapia, and today we are diving deeper into the world of artificial intelligence with Marta Duque. Marta is a PhD candidate, lecturer, and research associate at the Technical University of Munich. And as you can imagine, she has specialized in AI. In our last episode, we discussed the definition of AI provided by the EU AI Act, and we'll learn about adaptiveness, layers of autonomy, various AI applications, and the associated opportunities and risks. We will play a game, what is AI and what is not, and heard about Marta's experiences with feedback and initiating challenging conversations. Today, we will explore the difference between AI and machine learning, developing a machine learning model, how machine learning models can create biases, potential pitfalls in training machine learning models, assessing a model's ability to generalize, the concepts of overfitting and underfitting, supervised versus unsupervised training methods, deep learning and its different layers, and the difference between input and a prompt. As you can see, we have a packed and exciting podcast ahead. Let's start with the first question. What is the difference between AI and machine learning?
We have different techniques. The most important one is machine learning. They are pattern recognizing systems, so they learn to make predictions on new data by fitting past data.
If I understand it correctly, you get now data, you feed it in the system, and then this system creates a new data.
Yeah. It can be used, for example, to generate new music or pictures or text, as we are seeing. But it can also be used to predict the prices of the real estate in next year, or the life expectancy, or whether you have cancer or not, even if it's an early stage. So it can be used for many different things, but fitting past data.
Okay, so I assume then that ChatGPT and the similar ones are machine learning.
Yes, indeed.
Wonderful. But how do you distinguish between machine learning models and traditional software?
Yeah. In traditional software, the programmer writes step by step some rules that we need in order to solve a problem. Then they put the data into the system, the data is processed following those rules, and you obtain the output that you want. In machine learning, the process is reversed. So then we create what is called a trainable model. We put the data into the model. The model is trained, and then we obtain the trained model that is somehow the rules that we can apply on new data. So we don't program the rules. We obtain the rules that we can apply later on.
I see. So we see kind of the reverse system being applied for machine learning models than for traditional software. Now imagine you want to, or I want, my zero knowledge technical part, to develop a machine learning model.
Yeah.
Which are the necessary steps?
First of all, you need to determine what problem do you want to solve. And when you have this problem clear, you need to evaluate whether you have the data to do so, or whether you can get the data. There's a common misconception that, okay, if I have a lot of data, I can do machine learning. No, those data needs to have the patterns that you want to predict.
What are the patterns?
They need to have the characteristics that are going to help you to solve the problem. Let's say that we want a model to learn how to speak Spanish, so generate text in
Very
Spanish.
important.
Yeah. we have the copyright issue, right? So probably we'll say, yeah, but copyright is not forever. So I'm going to take all the old books like Quixote, Cervantes, and I'm going to feed the model. Basically, text, images, sounds are protected by copyright. And unless you have a license or the copyright has expired, so it's 80 years, I think, after the death of the author, you cannot use those material without infringing. So this is dangerous because if someone complains, you have to pay damages. So yeah, not a good idea. So let's say we kind of get all the old text and we feed them into the model. Is the model going to speak Spanish? Yeah, but which kind of Spanish? Probably there are a lot of words that we don't use anymore, and there's a lot of words that we use that are not there. Or the same, we want a model to speak like informal Spanish, and we want to avoid copyright issues. So we are going to try to train it with legal text, rulings or directives, regulations in Spanish. Our model is going to speak very formal and it's going to have a lot of law vocabulary, but it's not going to be able to speak like informal Spanish. That's what I mean, that you need data that really helps you with the problem. So having a lot of data sometimes can be relevant.
So it's about having the right
data. The right data. Indeed, not only a lot of data, but high quality data.
I understand there's also a process of cleaning that data. Is this done more for human?
Yeah, but this is a different, when you have the data, you obtain them in a raw form, and then you have to work with the data so that they can go into the model and be useful. Data sometimes have mistakes or values that are repetitive or the format is not correct. So you have to clean the data, so eliminate all these mistakes that they have. And finally, you also need to transform those data into a format that the model can understand, that is numbers. So with pictures, for example, there are pictures that aesthetically are very beautiful, but they are not fit for object recognition. And why? Because they are too beautiful and we want the model to act in the real life. And we don't see this brightness and lightning and so on. So sometimes they are converted into another scale of colors and the brightness is removed. They have to work with the data, let's say. Coming back to the topic of the phases, once we have our data, we were saying, we have to start with the training. And this is about finding different parameters that get adjusted. And at the end, they learn the patterns on the data. Once we have the model, we don't need this training data anymore. Because the model, if everything went well, learn the patterns and is capable of performing on new data without seeing those data that were used in the training. And this is what is called generalization.
Okay. So it's kind of educating the
Indeed.
system
until
it knows how to do it. Then reacts to the new data and then generalizes.
Exactly.
So this generalization.
For example, if I give you a picture of a dog, the model will tell me whether this is a dog or a cat, and it will do it correctly. And the picture that you are showing to the model was not part of the training data set. This is generalization.
Okay. And that connects to the whole discussion of bias if the system has not been trained in the right way. Maybe you can explain this.
Yeah, with the biases, we were saying that the model can only predict what is there. So if we use all data, or data, we want to apply a model here in Europe and we use data from other countries, they are not going to really reflect the characteristics of our society. And this is what is called normally bias. And if, I don't know, if we use all data, probably they are going to talk mostly about men. Now we have more data about women as well, and women have other kind of role. So we need to adapt the data to what we want to predict. Otherwise, the model will discriminate. And not because the model itself came up with something weird. It's because the data is showing a pattern. That's what is there.
So it is still on us.
It's still on us, indeed. And which kind of data we want to give to the model.
Mm-hmm, mm-hmm. So what can go wrong in the training of machine learning model, and how to assess whether the model is capable of generalizing? Because this seems to be really very important.
Yeah. Let's say that the training is a battle between what is called overfitting and underfitting. Overfitting is that the model learn the examples, learn the data, but is not getting the patterns. So let's try to put it simple. When you see a dog, why do you know that this is a dog and not a cat? Because you know that they have the nose and the ears in a certain way. So we want to do the same with the models. We don't want the model to memorize or to learn not all the examples of dogs. We want the model to learn the patterns. So overfitting is too much training that at the end the model learned the examples and not the patterns.
And the underfitting, I guess, the other way around.
Yeah, the model is not getting it. Maybe the data has a lot of features that were not necessary and the model cannot deal with that, or maybe you are using a type of model that is not fit for the task at hand, but the model is simply not learning. When I was reading about this topic, I found a very funny but also illustrative example. And let's say that we have a student. He was partying for the whole semester, then the exams come and
they never do that.
Never. Yeah, never.
It's a very theoretical example, but
exactly.
Okay, let's go with that.
And then the exam period comes and you realize like, wow, now I have to learn 1 month. I need to learn the civil code or the notes, what I'm going to do, learn it by heart. So probably if the professor in the university asks you in the lectures, do you know this specific term? You will tell the definition. And if you learned it by heart, you are going to do it right. But then in the exam, the professor doesn't want theoretical concepts and comes with a practical case.
Then exactly. You have a problem.
Then you have a problem because you don't know how to apply it. You just know everything by heart. Overfitting.
Overfitting.
Indeed.
I understand there are different training methods.
Yeah.
I have heard about this supervised versus the unsupervised part. What is this?
Okay, we have supervised and supervised and reinforcement learning. Reinforcement learning was the one that I was mentioning before of giving penalties and rewards. But what we have nowadays is mostly supervised learning and unsupervised learning. Supervised learning, we give the model the data with the example of what we want to achieve. And this is called label. So you give the model a picture of a dog saying that this is a dog, or with the traffic signs. Tell whether this is a limit speed sign or a stop sign. So you tell the model what the output should be, what it should predict in the future. And normally supervised learning is used for two different types of tasks, so regression and classification. Let's start with classification. Then the output is going to be a category, the dog and cat example. The output needs to be the classification of a picture in one of these two categories, right? And regression is about predicting outputs that are numbers. So we are working with real numbers. This is, let's say I want to predict the real estate prices in the next year. you are not working with categories. Then we have unsupervised learning. Here we are giving the model the data without examples, without labels. So we want the model to tell us the structure of the data, to discover somehow the patterns that are there. And this can be used, for example, for anomaly detection or for clustering or generative models that are the ones like ChatGPT or those that are generating new images. Normally, the models are trained with unsupervised learning. But let's talk about association, that is unsupervised learning. The recommendation systems. This is, if you like this product, you may also like this other one. Right? This is a task for unsupervised learning. And clustering, customer segmentation. Let's say that I have a supermarket and I want to know the habits of my consumers. How I'm going to obtain the data with the loyalty cards. And then I want the model to classify them in different groups. So let's say those that have a low budget or a high budget, those that eat vegan or a lot of meat. I give the data. I give also the groups. So the clusters, it's not that the machine comes with the cluster itself. And then the machine is going to classify the data in different groups. And we adjust it. Normally, there is a trade-off between unsupervised and supervised. It's not that we apply one or the other. There can be a mix.
Okay, so you were talking about the loyalty cards and then all the information and the possibility then to identify. And I had to think about this article I read a couple of years ago about one American loyalty card. The title of the article was "The Supermarket," I'm not going to say which one, knew she was pregnant before her parents knew about this.
I know this example. I use it in my business law lecture, actually, when I was explaining the GDPR.
Yes. So maybe you can tell a bit to the audience about this example, because I was totally shocked.
I think, indeed, that because of the information that they got, the loyalty card, they could predict that she was pregnant before she knew, and then they started to send recommendation of pregnancy products.
And she was minor.
Exactly.
And then the father was totally upset. So he was saying, why are you sending my daughter all this information? She's too young and we don't want to promote her to be pregnant. And then it was, at the end, came out that she was really pregnant. So now they are manipulating the advertisement so that you get a mix, for example, pregnancy products with maybe one bottle of wine. So that you realize you are being manipulated.
That's clever. But you're probably going to be surprised that when I was giving this example to my students, I wanted to determine whether if you are collecting the data for personalized advertisement, you should also, under the GDPR, be able to use those data for predicting pregnancy, whether they think that this is, apart from legal, whether they thought whether it is moral. And
morally correct.
The class was divided.
And I can understand that.
Yeah, there were a lot of students saying, like, why not? They should know, and sooner or later they will know anyway. So why not in this way? And I was like, well, I would prefer to probably know it in another way and in another environment, and because other circumstances. But
so it has benefits too. And at the end, is what we mentioned before. When do we want or need to regulate, and when not? And this balance of interest.
Indeed.
Yes.
And before we move to another topic, I want to also play a game with you.
Oh my God, it's coming back.
You did it to me, now it's my turn.
All right, so I'm just gonna play it. I'll blame herself. Okay.
I'm gonna give you some tasks.
Now is my face red.
Yeah.
You cannot see it, but okay.
And you are going to tell me whether we use supervised or unsupervised learning.
Okay, the supervised was the one that of the dog and the
Indeed.
picture of the goat.
And also the prices of the real estate. And then unsupervised was the recommendation Netflix system. And
Okay, let's go for it.
so for estimating the life expectancy.
Okay, supervised?
Indeed.
Okay, yay!
Supervised regression. We are working with numbers, so that was correct.
Okay.
Then you know that Gmail classifies your email in spam and not spam.
Oh.
Yeah.
Okay.
So is it supervised?
Unsupervised?
No. This is like the cat and dog example classification.
Yeah. Okay, that was a lot of information. You see, that's why it's good that we are playing this.
I understand.
So this classification will then become to the supervised. Okay.
Indeed.
Mm-hmm.
And finally, targeted marketing.
That's unsupervised.
Indeed.
Yay!
Good. You got it.
Very good. Very good. Now we can move to the next one before I get another test. I think it's like having the exam, but without the month.
Yeah.
Week.
No, you didn't have the opportunity to underfit or overfit.
Very good. What about deep learning?
Yeah, sometimes it is used also as a synonym of machine learning, but it is not. It's a branch of machine learning, and it's used when the task is super complex and the data are also super complex. So ChatGPT or these generators of images. And before I was mentioning these pictures of AI in which you have a neural network. This is deep learning. We have several layers, the input layer, the hidden layers, and the output layers. And for being deep learning, we need more than 2 hidden layers, so those that are in the middle. And why do we need so many layers? Because we need more levels of abstraction. So it's like we need to identify the patterns to learn are more difficult. So we need more processing. For example, working with images apparently is very hard. So that's what we need, these kind of systems. I read that sometimes, because deep learning is now a sexy topic, companies are asking, like, for this task, you have to use deep learning. The programmers are like, yeah, but it's not necessary. Actually, I can use a more simple structure. And they're like, yeah, but for getting finance, you need also to promote it. So,
oh wow,
deep learning is really for complex tasks, but not every task that can be solved using machine learning needs this complexity and also this energy.
Tell me a little bit more about these layers.
So the input layers are the ones that are receiving, let's say, the data. Then we have a lot of hidden layers. So those are the ones that are processing data and learning the patterns. And finally, we have the output layers. So are the ones that are giving the result.
Can you explain the difference between input and a prompt?
Well, they are very similar, actually. Prompts are used in generative AI models. They are those models that are capable of generating new content, such as images, sounds, text, so ChatGPT. We give instructions to the model, right? So input data. Before we were saying the data of a person to predict whether the person has cancer or not. Here, we give the model instructions, so it generates the output. We tell to the model what do we want. So ChatGPT is not coming out of the blue saying something. We need to ask, for example, write me a text about that. Or in case of images, you need to tell the models what they need to create. So I don't know, I love owls, so I want a very big and beautiful owl, pink and flying, I don't know. This is a prompt. It's how you interact with the generative AI model.
I can also add a document, maybe, or some pictures and say, I'm looking for something similar to this.
Indeed.
Is that an input, what the attachment that I include?
This can be a prompt. You upload the picture or the video or the sound, and then the model has to create something on the basis of this picture. This can also be a prompt. But yeah, that's why I say that prompts are usually used in the generative AI field, but the difference with inputs is not that big.
Exactly. That has been all for today's podcast. As always, we look forward to receiving your feedback. You can reach out in LinkedIn under Claudia-Tapia or via email at ipwithclaudiatapia@hotmail.com. Connected, we go further.